Okay, today is going to be about binomial expansion, which is 9.4, day 1. But I really want to start with a review because we're going to have a test here in about a week or so, and I want to kind of get you ready for that test. One of the big parts is these guys. Do you remember what that means? What's the big squiggly thing mean? Sum of a whole bunch of what's? Numbers, yes, they're called terms in a what? In a sequence. Good. What's the first term in the sequence? Well, you take a 1 and you stick it in there and you get 2 to the 1, which is 2. What's the next term in the sequence? You just take a 2 because we're going to progress gradually from 1 to 4. We take a 2 then and stick it in here, and it's 2 squared, which is 4. And then the next one, 2 to the 3rd, which is 8, and then 2 to the 4th, which is 16. Do you get that they really were asking me to add up 2, 4, 8, and 16? The first 4 terms in this sequence. Is that geometric or arithmetic? It's geometric because it's multiplying by something each time. What was the R? The ratio, the thing you're multiplying by. Yes, 2, because you could always get that by going that divided by that. Does that ring a bell? That's how you get your R. All right, now let's do this one that's arithmetic. That would be like this, sum of from 1 to, let's say 5 this time, of 2n plus 1. I'd like you to find me not all 5 terms. Find me the first couple terms, and then try to remember the formula that would add up all 5 terms. If you can't remember it, I'll tell it to you in a moment, but find the first couple terms. Try to remember the formula. I'll remind you, little Friedrich was asked to add up the numbers from 1 to 100, and he went back in a corner and he did what? To add up those numbers from 1 to 100. All right, I'll pause for a second. I'll give you that. You give that a try. Okay, so here should be the first start of your thought process. Okay, I got to stick in a 1. Stick in a 1. You get 2 times 1 is 2 plus 1 is 3. Then you stick in a 2 because you're marching from 1 to 5. And you stick in a 2 next. 2 times 2 is 4 plus 1 is 5. And then hopefully, just from that, you'll start going, oh yeah, this is the kind that's going to do what each time? Add 2. How could you have gotten that? Well, you could have just taken that minus that. Now you might think, well, how could I have known that it wasn't a power one where you're like, oh, sorry, I shouldn't have said that. That's how you can know. Because there wasn't a power in here. This kind is the kind that's just going to add 2 each time. That's called arithmetic. All right, if it's arithmetic and it's adding 2 each time, to remember, if you have 5 terms, well, we could probably write out the 5 terms pretty fast, so I might as well just to kind of show you the process. 3, 5, 7, 9, 11. There we go. There's 5 terms. Add them all up. Yeah, I can do it by hand. But, do you remember? We taught you how little Friedrich did it, which was a pretty smart way. He took the first term and the last term, and he took the first and the last, and then he added them up, and then that was the answer? No. He added them up, and then he multiplied by half of how many terms there were. 1, 2, 3, 4, 5. So you multiply by 5 over 2. So final answer, 11 plus 3, 14 times 5 over 2. I'm going to change this 14 to a 7 times 2. That's always my prerogative. And then I can go 2 cancels the 2. 7 times 5, 35. Raise your hand if you had that one right. Okay, good. Now, some of you did it the caveman way, or you just found all 5 terms and add them up. I know that. But do you remember the formula for this? It looked like this. S sub n. That's kind of vague because it works for any sum, and this happened to be a arithmetic. And I wish I would have started going like that. Sub a, which would mean the sum for an arithmetic is, and I'm not going to force you to remember this, but it was the first term plus the last term. Does that ring a bell? First term plus the last term. And then we times it all by, anybody do it? N over 2. That is a formula that you would be given on the test, but you'd have to be able to use. Let's see if you can use it right now. Let's say I'm adding up this one. 1 plus 5 is 6, plus 5 is 11. And let's say I wanted you to add up the first 100 terms. Obviously, you're not going to do that one the caveman way. So add up the first 100 terms. I'll pause for a second while you use that formula to do the work for you. Okay, so you're going to put 1 in there. I agree. Okay, and then what else we know? N is 100. The total number of terms we're going to add up is 100. Okay, good. And then D is 5, and A is also here, so I'm going to put a 1 here and a 1 here. And D is 5. And then what? So what's this N minus 1? Which is 99. Okay, good. So then I go 5 times 99. Might be easier to do 5 times 100. And then subtract 1. Do you get why that would work? 5 times 100 minus 1 is the same as 5 times 99, isn't it? And it's so much easier to do in your head. 500 minus 5, 495. Get what I'm saying? All right, 495 plus 1, 496. Plus another one, 497. So this whole is 497. And then I'm going to times it by 100 over 2, which is the same as 50. And then it's 50 times 497. This I'm going to probably have to do the old-fashioned way, put it times 50 here. Would you save me some time? 44 what? Oh, 24 what? 24850. Can anybody verify that number? Quite a few people. Okay, good. All right. So that is, in essence, the main thing that you learned. But then right before you left, we went into infinite series, and there was a special formula for that. Yes, sir. This whole thing is the last term. Yes. And the last term is given by, that's that formula, A plus D times N minus 1. Does that ring a bell? That's what gives you the last term, or any term. Here, I'll give it to you this way. A sub n is your amount that you started with, plus D times N minus 1. And I know there's two A's here. This is the starting term, and this whole thing here is the ending term. Okay. All right, so infinite ones. 1 cuts in half to a half, cuts in half to a fourth, dot, dot, dot. This really bothers me, and I hope it bothers you, that if I add this up to infinity, I can get an answer. How can you keep adding forever, and yet I know the answer already? Just doesn't make sense. But at least it bothered the Greeks, who were really good thinkers. All they had to do all day was sit around and think. I know, they had to do other things too, but this is the sum of what? How would you write that as a sum? Not the answer to it. How would you write this as a sum problem? And then let's see if you remember the formula for infinite kinds. I'd like to put a little infinity down there because S sub n, this could be the sum of anything. This is an infinite series. I'll pause for a second while you give that a try. Okay, what do you think? All right. It is to the power of n minus 1, and then you said a over 2. That might work. Okay, then tell me more. What goes here and here? 1 to infinity. Excellent. Okay, now how can I know if he's right or not? I can try to develop the first term. I stick a 1 in, and I see if this works. When I put in a 1, I get 1/2 to the n minus 1, and I got 2 variables in this thing. So you're close, but I can't have 2 variables here. Get that? I only have 1 thing to put in. I can't put it in both of them and act like A and N are the same thing. So something went a little wrong with that one. Who's got an alternative answer they think might be right? What do you think? Okay, so you're thinking, this could be 1/2. All right, excellent. 1/2 to the n minus 1. And then, wait a minute, where's my starting term? It's 1. It's important to note, though, that if there was a starting term, it would be right there. Okay, so let me show you the easy way to get those. Here's the really easy way. You take that, you stick it here. And then you just put in what you know. What do we know? A or R or both? We know A is what in this case? 1. So I put a 1. What's R in this case? Yeah, because you can take that divided by that. Find out that it's multiplying by 1/2 each time. That's how you can get it the easy way. All right, let's see if you can do one since you weren't awesome at that one. Let's say I took 8, and the next one is 8/3. And I can tell you it's a geometric. And I'd like you to tell me, if I wanted you to just add up the first 4 terms of this thing, write me the sigma. Write a sigma for me. Put it in a sigma form. That would tell me the first 4 terms. I'll pause for a second while you give that one a try. Okay, so you should have said to yourself, what goes here? Well, this part's easy. It's just from 1 to 4. But what goes here? Oh, yeah, he said to put the formula there. So I don't need the a sub n part, but I need the other part. Oh, yeah, a times r to the n minus 1. And then I know what a is. A is the starting term, and it's 8. And then I know the r by e. That divided by that. That's a pain. Couldn't I just, like, think it through and think about what did I multiply it by? Oh, yeah, I multiplied it by what? 1/3. Now, I could have gotten it by 8/3 divided by 8, but that's a pain. So I could just look at this and go, what did I multiply by? I multiplied by 1/3. So the r is 1/3. And there you have it. That's a blotch. 8 times 1/3 to the n minus 1. That's how you write it as a sigma problem. Raise your hand if you feel like you understand that. Okay, good. Then let's talk, again, kind of go forever. It starts with 2. It goes down to, multiply it by 1/3, 2/3, and then it goes forever like that. Would you please figure out what the sum of all of the terms are using this formula? Can anybody tell it to me before I write it? You remember it? It is 1 minus r. Excellent. Use that formula to tell me the sum of that infinite series. Okay, let's see if you were smarter than the average 5th grader. When you have a formula, and you just got to stick stuff in, that makes it a pretty easy question. This is like an R2 level kind of thing. All right, if I have an A, that's the amount I start with, 2 over 1 minus R. Well, it'd be kind of nice to know what R is. Oh, yeah, I take this divided by that, which means really 2 times what made 2/3? 1/3. And therefore, R was 1/3. And therefore, this is 2 over 1 minus 1/3 is 2/3. And hopefully you remember that that's the same as 2 times, flip it, 3 over 2, putting this over 1, 6 over 2, which makes 3. It would add up to 3. Oh, yes? So you just knew that this was going to add up to 3? Okay. The problem with that argument is that okay, I get that you might have caught onto the pattern by now, that you can just kind of do them in your head. I'm going to expect to see work on your test. That's all. Just show me your work. You're not going to be able to just say, well, I could just tell. Because otherwise, if I set that up that that's okay, then the kid who's the copier in here, I'm not saying there is one, but imagine that there was. If he gets it all approved by the teacher to just be able to write the answer down, all he has to do is be able to lean over a little bit to the right and look at the smart girls test and go, ooh, the answer is 64. I did it in my head, Mr. Server. You get what I'm saying? All right, you have to be able to show how you did your work. Drawing a detailed picture of your brain will not be acceptable for showing the work. All right, anyway, moving on. We need to get to the new stuff. All right, the new stuff has to do with, I'm going to show you, like, at first this is going to look like, holy cow, this is insanely hard. Go back to the very beginning, first slide here, and it uses this formula. Woohoo! Complicated, but I can show you how this works so much easier that I think I'm going to wait and not even use that formula until after you've done a few of them and go, oh, I can see how this would fit into the formula. I tried one year teaching it where I just said, here's the formula and let's do some, and oh man, that would not go well. But I think you're going to feel like this is easy if I show it to you this other way. All right, so find this slide that looks, oh, by the way, if you had forgotten, we did the bouncy ball thing, and I'm not making you write up the lab for it. Just a reminder, what kind of a sequence was that? Infinite, and is it adding something each time, subtracting something each time, or multiplying by something each time? Multiplying. That would be a geometric infinite series, so we use this sum of this infinite. I'd like to put a little infinity here. Would be a over 1 minus r, and all we need to know is the start, and then r, which was the bounce height. In our case, we started at 100 centimeters, and it went up to, like, I think your class was 92. Does that ring a bell? Or 88 or something like that? That depended on the kid. But we think we picked the best ball in here was like 92. Anyway, and then that's just a quick reminder that that's something we did do already. You're done, and you don't have to worry about that. Back to the actual page. I think it's like, it's like a purpley color. There it is. That one. Find that one. Would you agree that a plus b to the 0 power equals 1? Because anything to 0 is 1. With me so far? Okay. What if I take a plus b to the first? Well, then it's just 1a plus 1b. I'm writing this out because we need to establish a pattern here. Because eventually, you're going to be having to do things like a plus b to the 14th power. You're not going to be able to just multiply them out by hand. You'll need a way. This is called binomial, because this has got two parts. Expansion, meaning you're multiplying it all the way out and expanding it out to this huge answer. You will do really big, scary ones. So we need to learn this pattern. Don't just know, well, I'll just multiply them. A plus b times a plus b. Yeah, when it's to the 7th, you'll have to do that 7 times. And can you imagine how complicated it gets by the end and how many little pieces you could forget? All right, so we're trying to establish a pattern here. So a plus b squared is a plus b times a plus b. And so the first term of that would be what? A squared. Then what? And I'm going to note that that's 1a squared. Do you agree? Now, those numbers become important, and you'll see why in a moment. And then we do the outside and the inside, which I'm going to call BAs because it's kind of fun to say BA in math class. Anyway, if I say that there's 2 BAs, then it's 2BA. Put a 2 here, and I'm going to say this is a and a B, and it doesn't matter if it's BA or AB. I'm going to start doing my B's in red. I'm going to change this B to red. You don't have to color code this thing, but I am. And the little connector ones, they can just be little black pluses. And then the last is what? B squared. And what was the number on that one? 1. All right. Without having to actually multiply out a plus b times a plus b times a plus b, which you could do it by taking this, which is what 2 of them make, that's like these 2, and timesing it by this. And you could do it, and it would just take you a while. But I'm going to see if you can catch on to the pattern already. Excellent. What do you think we should do for our a's then, Mr. Wizard? A to the third. Okay, now, let's just do the a's. Let's just go through and do the a's the whole way. What's this spot's a's. You have not caught on to the pattern, but you thought you had. Nope. It's not 3a. It's not a to the third. What do you think? Anybody else? What do you think? A squared. And the next one? A. And the last one, I know it seems like there should be an a there, but couldn't we say it's like there's an a to the 0 there? Which is really like a 1. So it doesn't matter. It doesn't really need to be there. But now let's go through and do the b's. Did you catch on to what the b's were doing? So what do you think the b at the end here should be? B to the what? Third. And then this must be b to the second. This must be b to the first. This must be b to the 0. Exactly. And now this last pattern is the toughest of them all. The green numbers. 1, 1, 1, 1, 2, 1. You really close. Different guy, not that. Yeah. Yep, it's that triangle. Can you figure out what the next terms are then? Nope. Let's just guess random numbers. Okay, how about this? How could I have gotten this 2 by looking up here? Yes, yes, go ahead. It's 1, 3, 3, 1 is correct. And let's see if anybody can figure out the guy. It's Pascal. Pascal's triangle is correct. Very good. Okay, so now the question is, how did I get the 1, 3, 3, 1? Anybody tell where the 3's came from? Yes, sir. Yes, that and that make that. And the 2 and the 1 add up to that 3. So I'm going to just do Pascal's triangle separately. 1, 1, 1. 1, 2, 1, because 1 plus 1 make 2. You know what I'm doing here? 1, 3, 3, 1, because 1 and 1 make, or sorry, 1 and 2 make 3. And this 1 and 2 make the 3 right there. I'm going to make that a. So what do you think is next in Pascal's triangle? 1, 4, 6, 4, 1. And I want you to notice too, how many terms did that one have? How many terms does that one have? How many terms does that one have? It just goes up 1 every time, right? Okay, that's cool. So let's look back at this and see what pattern we had. Oh, so messy. But do you get that this had 1, 2, 3, 4 terms? So we needed to use that line of the Pascals that had 4 in it. But look, it has a power of 3 and yet has 4 terms. This has a power of 2 and yet has 3 terms. This has a power of 1 and yet has 2 terms. This has a power of 0 and has 1 term. You get what I'm saying? All right, so moral of the story is you can make these by having a pattern, a plus b to the 5th. Right away I would go, okay, I need how many blanks? 6. Everybody try this one. I need 6 blanks. First, go through and do your A's. Think about it. If I was going to do A, one of the first things I'd do is A times A times A a whole bunch of times until I ended up with A to the 5th. And then it'd be A to the 4th. Keep going with that pattern. Let's see if you can do it without me. I bet you can. The hardest part is the Pascal's triangle thing, which you can always go back and draw on your test if you need to. I don't expect you to memorize that the 6th line of the Pascal's triangle is 1, 3, 6, 9, 4, 2, 1. It's not, by the way. Let's see how fast I can write Pascal's triangle. Go. Stop. Okay, that was like 9 seconds. And look at me. I've already got all the lines I probably ever need for a test, because we're not going to make you do this to the 17th. Okay. All right. So did you get a to the 5th, a to the 4th, a to the 3rd, a to the 2nd, a to the 1st, and a to the 0? And when you clean it up at the end, you can get that a to the 0 off of there because it's really just 1. Then you go through and do your b's, and this will be b to the, not 5th, b to the 0, b to the 1, b to the 2, b to the 3, b to the 4, b to the 5. And then the last thing is I need to squeeze in those Pascal triangle numbers. This is the one that has 1, 2, 3, 4, 5, 6 numbers in it. This one had 5 numbers, so I'm going to have to go one more on this chart. 1, and then 1 plus 4 is 5. 9 and 4 makes 13. 9 and 4 makes 13 again. 1 and 4. Oh, dang, I keep doing that. I did it last hour. 3. It's not 3 times 3 is 3 plus 3, and that's a 6. So the 6 and 4 would make 10. Thank you. So sorry of those following along at home. 6 and 4 makes 10, and then 4 and 1 makes 5. And then you know you haven't done it right if you're ending on a number other than what? It always has to end with 1. Okay. So 1, 5, 10, 10, 5, 1. Raise your hand if you had the same as that. Okay, good. So I'm going to squeeze those in now. Make them green. 1, 5, 10, 10. 5, 1. And there's pluses in between there. So now I'm going to clean it up. I want you to do that too. If you left this for me on your test, I would call it unsimplified, and therefore, at minimum, you'd lose half the credit, which really sucks because you pretty much had it. All right, so let's simplify it down. This would be 1, doesn't need the 1, a to the 5th. I don't need the b to the 0 either. And this will be 5, a to the 4th, b. And yes, you could say b to the 1. I wouldn't mark it wrong. And there needs to be a plus in there. Plus the next one, 10, a to the 3rd, b squared. And then 10, a squared, b to the 3rd. And then 5, a, b to the 4th. And then I can't fit it here, but the last is plus. The 1's unnecessary. The a to the 0 is unnecessary. B to the 5th is your very last term. Raise your hand if you feel like I understand that. Okay, good. So here's where they make it more complicated. It's not super complicated, but it's actually simpler. What if they said, all I want is the coefficient of the second term? I would not, if I were you, try to figure out and memorize some fancy way to figure out that that is the second term and that answer is 5. I would just do the second term. Do you get it to be a lot faster? You don't have to go and do all of these terms. Just do it out to the second term, and then you got it. So let's do something like that. Let's say it was a plus y. I'm just changing the letters up on you. To the 3rd, and I want to know the second term. Just the whole second term, not just the coefficient. Just figure out the second term. Personally, I'd still make 4 blanks. But I wouldn't do all of them. All I care about is the second term. You have it already? Excellent. Okay, tell me how I would start. I'm talking, I want you to do the first couple terms because then the second one is the right one. But so let's start with a to the 3rd, and then what? Okay, hold on. Let's just do our a's. A to the 2nd, a to the 3rd, and then do I really need to do these? No. Now let's go through into our b's. This would be b to the, oh, in this case, y. Y to the 0, y to the 1, And then I can go back and do my Pascal's triangle that's got 4 spots. That's 1, 3, 3, 1 if you want to memorize it. And there we go. And then which one was important? That guy. 3a squared y to the first. Raise your hand if you had that one right. See, it's faster because you don't have to do all of them. You can just do the term that they care about. All right. What happens when they get more complicated? Well, here's how they get more complicated. 3a plus 2 to the fourth. Notice that that one has a number on the a. Would you just do, there's 5 blanks. Would you just do the first 2 terms of this one? We'll see if you've got your patterns down well enough. And if the first thing you do is 3a to the fourth, you lose already. Because something's wrong with that. I hope you get what. If you don't get what, I'll explain it to you in a moment. But try to do the first 2 terms. That's all I'm asking for. I'll pause where you give that a try. Okay, so here we go. You should have started with 3a like that to the fourth. Do you get why? Because this whole thing needs to be put to the fourth, not just the a, the 3 also. All right, and then I'd go on and say 3a to the third, and then 3a to the second down here, and da 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 da. But all I have to do is the first 2 terms. Then we go through and do the other one, which is a 2, but you do that in ascending order, where the 2 is to the 0 first, 2 to the 0, and then this one has a 2 to the 1 on it. You get what I'm saying there? And I would have kept going and said this is 2 to the second, 2 to the third, 2 to the fourth. And then I have to go back and do Pascal's triangle. Just because it's got a number in it already doesn't mean we don't need those Pascal's triangle numbers. And this is the one with 1, 2, 3, 4, 5 terms. So if I look back to my Pascal's triangle, the one with 5 terms is this guy, 1, 4, 6, 4, 1. So now I'm going to go back into here and put 1 and 4. Now I'm going to clean it up. 3 to the fourth is 81 because it's, and that's 9 and that's 9 and it makes 81. Okay, 1 times 81 is 81, a to the fourth. And 2 to the 0, this little part here, that's really 1, so it doesn't really do anything. Plus 3 to the third is 27, and then 27 has to be times by this 4. $108. And that's, oh wait, and then there's an a to the third times a 2. That 2 has to be times by the 108, which makes it 216 a to the third. Can anybody concur? Got the same answer as I did. And those are some of my top students, so I think we're right. All right, I know that you got a little bit scary at the end there, a little bit tougher, but let's just do one more with a little bit simpler. 4a plus 1 to the third, but just figure out the first term of it. No, sorry. Just figure out the second term of it. I know there'd be 4 blanks. 4. Just figure out the second term of it. See if you got this now. By the way, if you're having trouble with 4 to the third, anybody got it? 64 is correct. So it's 4a to the third, 4a to the second, dot, dot, dot. And then this is going to be 1 to the 0, 1 to the 1. And that's the same thing, which is weird, but true. This will be 1 to the second, 1 to the third, blah, blah, blah. Don't really need those. And then the last thing is I got to figure out which one of these Pascal triangles I'm on. Okay, and this has got 4 spots because this is the power of 3. And that's the 1331. Did I memorize that right? Okay, good. And so that means I have a 3 tacked onto this. So there is my answer if I multiply this by 3. So now I'm going to go 4 squared is 16. 16 times 3, help me out. What's that? 48. A squared was the second term. Raise your hand if you had that one right. Almost up to everybody. Good job. Okay, so last thing is just a preface for tomorrow. Some of your homework has this in it, but it's leading up to that big, nasty, scary formula. It has these in them. Do you remember what that means? 3 factorial, which means 3 times 2 times 1. Good. What if I said 3 factorial divided by 2 factorial? You could actually figure this out and say, what is 3 times 2 times 1? And that's 6 divided by 2 times 1. But you could cancel stuff. Do you get how that and that would cancel? And the answer is just 3. Okay? So what's 4 factorial over 3 factorial? That'd be just 4. Good. Because it's 4, 3, 2, 1 all over 3, 2, 1. And the 3, 2, 1s cancel the 3, 2, 1s. And the answer is just 4. Okay, good. Now, they might throw a few of those at you because we're getting you ready for when you have to do this, which means this, which means this. 3 minus 2 is 1 factorial with an extra 2 factorial. And then that was this. Does this ring a bell? You remember from last year? That's how you can figure out the Pascal triangles numbers without actually doing Pascal's triangle. So all you'll have to do on today's is a few of these things with factorials like this, just because we'll need them tomorrow. All right, so let's look at your homework together. It starts at bright green, if I remember it correctly, and it's like 30-some pages down. There it is. That guy. Okay, so we are doing the first 6 of them. We are skipping these, even though that just means 8C3. And I think some of you will remember that that's really 8 factorial over 8 minus 3 is 5 factorial with an extra one of these, 3 factorial. That's how to do that, but we're skipping this section. But these are just a warm-up for tomorrow, really. Now this, I only need you to do the first 2 terms of these guys, because this kind of implies that you should go forever. And I'd like you to just find the first 2 terms, and if you figure out that you don't really need to do that, that's okay. But I don't want some kid thinking you need, how many should I do? Okay, do at most 2, and then you'll figure out what's going on. 2 terms, and then hopefully the light will come on. Get how it starts at 0 with this one, and then it goes up to 1 and goes up to 2, and then hopefully you'll figure out what's going on. Okay, moving on. This is an expansion, just like we just did. There will be 6 blanks. Everybody, I'd put 6 blanks if I were you. And maybe just to be nice to yourself for later, get it started. This will be x to the 5th, and then what's next? X to the 4th, x to the 3rd, yada, yada. And then you're going to go through and do the 2's. It starts with not 2 to the 5th, but 2 to the 0, and then 2 to the 1, etc. And then don't forget Pascal's triangle. That's a really common mistake, to forget that you got to throw in the number in front of this, this, this. All these have a number in front of them from Pascal's triangle. All right, so I'm assigning the whole rest of it because I'm evil. No, they're really not that hard. So we stop there on number 18. And I think that should be a very doable, in 20 minutes, assignment. That's all I got for you for today.